Judy-anne. I am just delighted to be here in this amazing community. I'm delighted to be here at Macquarie and also for FYI Maths, and thanks to Deb and others here who started FYI Maths. Thanks to all the learning communities that are part of this. Thanks also to people online. It's a shame we can't see you, but they include some of the entrants in these art awards that I'm going to be announcing. So it's lovely to be able to know that you're there and know that you're hearing and listening in. So art awards, we do art maths awards. Don't even really think about it. But what art can do is can give us a different perspective, a different language, a different way in, a different way of connecting. So I really want to acknowledge that and the different communities that have come together in this forming. CARMA, which I'll talk about a little bit, Matrix. Also want to acknowledge this physical place, Macquarie University. I went for a walk at lunchtime and look at the cool stuff. I don't know, there's not a lot of locals around we found, but there's these amazing sculptures that I found. When I'm working around a campus, I didn't used to, but now when I'm walking around a campus, I think if I was teaching here, how might I use the campus in my teaching? And part of my becoming more aware of that sensibility has been my being involved in an Indigenising University Maths project. So now I also acknowledge Indigenous people and those learning communities that have been here for thousands and thousands of years. And I also acknowledge the sad break. That means that it can feel awkward to acknowledge that in a maths conference because we've got this deep, long learning community and we've got this other deep, long learning community, and sometimes it doesn't feel like they're terribly connected. But I am acknowledging both of those communities, and art, I think, is a space and a way for making connections. So I wanted to start by saying that. The CARMA-MATRIX Maths Art Poster Competition started at Newcastle University, and it was instigated by Riya Aggarwal, who's Dr Riya Aggarwal now. She was a student then. She was a student in maths and engineering, and she said, in engineering, we get to do heaps of cool stuff. In maths, we don't get to do anything fun. Why not? We should do some more fun stuff. And so we started the Maths Art Poster Competition at Riya's very energetic instigation, and it's been fabulous. And Matrix joined the partnership in 2022. Many of you will know Matrix and the important role that it plays in Australian mathematics, and they have a physical exhibition of awards at their Creswick facility. And a couple of years ago, it was in the Creswick News. There's yarn from Matrix. And there's some of the award-winning artwork from a couple of years back. So I also want to acknowledge John Baldwin and CARMA and how, in a way, this continues his legacy, because he was a really interesting thinker about mathematics. What is mathematics? What is proof? What can we know? What is belief? That connects very much back to the opening keynote that we had today. And he was also a believer in lots and lots of slides. If you ever went to a John talk, about 300 slides in a given talk, all of them reused many, many times. So it wasn't hard for me to go and find slides of John's about maths and art and the depth of that connection and the importance of that connection. That's John's brother, and some of the art of Hellman Ferguson, and an award in honour of John's dad, David Baldwin, mathematical family there, a sculpture inspired by some serious summation to do with salt. So start thinking in a really connected way. All right, let's get into the actual entries. So we've got two categories, art entries and outreach poster entries. We need more poster entries next year. Start thinking about it. We also need more art entries. Start thinking about it. I'll go through them in turn. This one is called Spider Fractal. And so intriguing how spiders come up year in, year out. Like, I think second prize a couple of years ago was this other incredible sort of spider web where somehow the web wove the spider in the maths. And here we have a spider fractal, and my slide view is not going to allow, yes. So the artists submit artist statements, And in this case, the statement is really hard to read. However, it tells you that this comes from another piece of fractal art called a burning ship. So in all of our words, we have these landscapes of connection and things that we can resonate. So playing around with a few complex numbers, some absolute values and reals and imaginaries and powers and stuff like that. And with computation, all of a sudden we have stuff like this and stuff like this. Isn't that so subtle? It's called the butterfly effect. It is one of two entries by different participants, both called the butterfly effect. And the artist statement, which I'm not going to be able to read, said something like, not only is the butterfly effect terribly important in chaos and maths and fractals, but some of them actually come out looking like butterflies, like this one does. And this one is called Millefiori. And again, it's related to these burning ship fractals. So maths art, there's layers of meaning and symmetries. And this is why I am a mathematician, because I just like pretty patterns. And I like seeing those pretty patterns in more and more depth and seeing different ways of seeing these pretty patterns. So this one, the artist says the recursive series resembles ornamental glass beads. And again, it's a little bit of complex numbers. Nothing that looks too tricky in an equation, but look what is there in the nature of it. And then something different. Whoa, look at that. Look at that spiral. Look at all those colors. Look at everything that's coming out in the celestial halo. It includes 50 spiral figures, each with a unique color and shape. And it was defined by polar equation R equals A theta, familiar enough. R and theta meaning the usual things, the random amplitude, and a bit that I can't see. But simple stuff. And yet, such richness there. And I think sometimes students, they do all this work and they get very little benefit. But here we've done this tiny little bit of work and we've got this huge benefit. And what's going on? Next one is something different again. This is a Voronoi tiling. It's a Voronoi tiling. The artist statement says it's a vivid exploration of randomness, order, and the timelessness of mathematics. It creates a Voronoi diagram based on random points with a bias towards what? Can anyone see what the bias is towards in the middle there? One of our most familiar symbols. Yeah, just look at it for a bit and look and feel your way into it. Okay. The color gradient echoes the infinite diversity within pi's digits, representing it not just as a ratio, but as an emblem of mystery and discovery, randomness within hidden order. Here's the other butterfly effect. Once again, a butterfly is just emerging from these equations that we have. What is it? It's just R equals B sine 5 halves of theta. And B is a random factor between 1 and 3. Converted to Cartesian coordinates with X is R sine of 2 theta and Y is R cosine of 5 theta. And implemented on open source programming GNU Octave. And it's a whole world we can play in. Here is the butterfly effect for the second time, different butterfly effect. And to change gears again, here is fish motif. Also implemented on GNU Octave, open source, free stuff. And we're back in the world of tessellations and geometry and tilings. And this way of seeing two-dimensional space. And if you want to go from two-dimensional space to three-dimensional space, you start thinking about what will tile in three-dimensional space. And oh, my mind goes there. And connections with nature. The next one is called algorithmic leaf. And usually you think of algorithmic leaf, you think fractals, and this is kind of fractally, it's kind of not. it's a hybrid kind of thing, generated by a combination of polynomial functions and fractals. The primary structure of the leaf was defined using polynomial functions, and finer venation details were added using a recursive fractal pattern. And then nature again, nature and mathematics, crystallized. So this is generated through an application of Lindenmayer systems, L systems, wherein a set of predefined rules iteratively transforms an initial axiom. By directing the trajectory and angles of drawn lines based on these rules, intricate patterns emerge over multiple iterations. And we just see the world anew. Lindenmayer systems. What's up next? The intergalactic moth. One of my favorite. Just into the infinite, into outer space, but then the very, very big and the very, very small. You think it's summer and you see the moths all around at the moment, fluttering around. Colour and space, distance. And R equals B sine 9/4 of theta. And then just x equals r sine of 5 theta and y equals r cosine of 2 theta. And you get that. So beautiful. And then let's shift gears again. Here we've got the golden ratio, which comes up again and again and again and again. And here's an architectural context for the golden ratio. This is in the art category. And I think it's also a really nice piece of outreach potentially. Spirals. My friend Andrew Keppert at Newcastle Uni, he built his own house and he's done spiral staircases and that sort of thing, and Galois theory, as mathematicians do. Oh, leap up in enthusiasm for this artwork called Enthusiasm. Bold lines and colour, so different to some of the others, and just reaching up and out. And here's anti-symmetry. And he's talking about the artist statement, which I'm remembering because it's not showing up. He's talking about not just difference, but similarity, and how the underworld is a reflection of the overworld. And we find that in mythology as well. So it's a metaphor. And then the next one, this sort of reaching up thing, I don't remember what the artist statement said for this one. But for me, this is sort of like an erupting, giving birth, sort of a volcano of a emergent thing. That's it's the Russian dolls. Deb is exactly right. Matryoshka dolls. That is the actual name, and then dolls within dolls within dolls. Thank you, Deb. Wonderful being part of a knowledge community. And here's something different again. Could you imagine this woven on your wall? Big, textured, coloured. The rest of things needs ulam. So this had to do with the primes being organised in a spiral, but being organised in such a, so Aristophanes would include the multiples of the primes as they're occurring, patterned in colours. So some of that is going on in this amazing textured array. And then something interestingly simple. It's called associativity. And I wonder what your feelings and associations are with that pattern. Blob and the curve and the reaching towards and the lines and the construction, and whether it's reminding you of constructions that you have done. And then we have, ooh, more colour, harmonical. Just You know, minds love patterns. And I think I can imagine just sitting and going, oh, what's going on there? What was the instigation? What is this trying to do? Why these points trying to intersect? They look like they're trying to intersect. And a lot of this work, of course, comes out of looking for out of optimization algorithms and trying to converge to a point, and some of the beauty that happens along the way. I don't know if this one does, but a lot of maths art visualization work comes out of that kind of context. Here we've got another kind of approach in the next one. This is called approaching an ACT node. Yeah. And then the next one, it's really playful. I really like it. Ba-doing! Around we bounce. Study of the ninth. There's some classic geometry there and some, you know, those interesting questions about whether you've got so many points and then whether there's another point that satisfies this type of rule. This is coming out of, there was artwork in previous years that were studying the same problem, and so we're seeing an evolution of some of the thinking in art that's coming out of this exploration. Next one's got a scary title. Scary for me. Whoa. Vicious. We've got these intense swirls going on here, and this intense meeting and parting and separating and coming together with these very, very vibrant colours. And then something a little more subtle. This one's called transformational. And you see the echoes within of what is without, and these subtle, subtle pastel colours. So those are the art entries. And we're about to announce the prizes to the art entries. And art prizes, the third prize goes to someone who's no stranger to this competition and who is online. Congratulations, Peter van der Kamp, again, for taking a prize again. Art competition. Erasta Thieves meets you, Lamb. And the artistic review included comments about the elaborate structure, the intense colours, and the sound concept that was in this artwork. So, well done, Peter. Second prize coming up. Anis Owen Sika and Honorada. I believe at least one of these people are here to celebrate beautiful intergalactic moth going into the galaxy, big scale, small scale. The artistic review was mesmerising, beautiful with a clear focal point and giving the impression of movement with all of these lines of colour. And then first prize coming up is to Jared Roberts for Prismatic Parchment of Pie. Something's just so iconic about pie. Great choice of harmonious yet contrasting colour palette, intriguing variety of shapes that encourage the viewer's eye to engage. Interesting piece to explore and discover. The pie symbol in the centre was the artistic review from that. So that's this year's art competition. I will go into the posters very shortly, but I'll comment. Next year, we're probably going to have a launch for the competition on Pie Day. We'll try and organise a pie type of talk or something like that. So I encourage you to come along. I encourage you to start thinking about all the different places where visualisation turns up in your own work, and you can contribute. Now on to outreach. There's just 2 entries in the outreach category, so we've got the prizes and the display at the same time. We thank the participants for their efforts. This entry, second prize, goes to CAN-SELECT for the transition from knots to rational numbers. And it's such a, like, knot theory is such a visual thing, such a natural topic for outreach. I'd love it if we had that poster and then some actual rope and swirled around and that sort of thing, and people could engage physically with it. I think that would be a really interesting display to have on a wall, and to be able to engage with. So great choice of topic and some fabulous information there from CAN-SELECT. And then the winner for the Outreach Poster competition goes to Wallpaper Groups by Ina Bach Pie. See pies everywhere. So the artists reviewing this really liked the way it was laid out, the eye-catchingness, the beauty of it, the accessibility of it. And yeah, so that is we better thank all of the entrants. That's the awards for this year. Thank you very much to the artists, to the judges, to the Matrix people who to contribute, to the CARMA people who to contribute, and to all of you. And looking forward to potentially lots and lots and lots of entries next year, possibly from some of you. So thank you very much.